Homogeneous equations. So basically the ones that can be written as y over x and then use a substitution of z equals y over x. And keep in mind, y, this is important, it's a function of x, z, it's also a function of x, and x is the independent variable. So let's solve dy dx equals y minus 3x over y plus 4x. So can I find these terms y over x to do my substitution? Well, if we divide by x the top and divide by x the bottom, and I'm allowed to do that because it's exactly as if I would multiply by 1 or divide by 1, I would get dy dx equals y over x minus 3 over y over x plus 4. So I'm getting there, right? So use the substitution z equals y over x. The problem is, so on this left hand side, I'm going to have z minus 3 over z plus 4. The problem is on the right hand side, on the left hand side, dy dx would create 3 variables in my equation. So I want to find the dy dx in terms of dz dx. So if we cross multiply here, we get y equals x times z. So dy, if we differentiate both sides with respect to, so differentiate with respect to x, which is the independent variable, we get dy dx, and on the right side, we use the product rule. So it's x prime times z plus x times z prime, right? So just to make it a little bit clear, dy dx is x prime is 1, so z plus x times dz dx. So if we solve, actually we don't have to solve anything because we are going to replace dy dx in here. So x dz dx plus z equals our equation. So we actually have to solve this equation in 2 variables, x and z. So let's subtract by z. So y dz dx equals z minus 3 over z plus 4 minus z. I need to have the same denominator, so we are going to multiply by z plus 4. And we do a little bit of algebra and get z minus 3 minus z squared minus 4z, everything over z plus 4. So x dz dx equals negative z squared minus 3z minus 3 over z plus 4. So we have to ask ourselves, what kind of equation is this one? Separable, which was the first one that we talked about. Is it linear? Is it exact? Does it need integration factors? And it seems like it's a separable one. So we are going to multiply by dx over x, and we get dz equals negative z squared minus 3z minus 3 over z plus 4 times dx over x, and then we multiply by z plus 4 over negative z squared minus 3z minus 3, and we obtain this separable equation that will integrate both sides, and then let's solve the integral. So you can pause here, try and solve the integrals, and then get the equation back into y and x. So if we use a substitution, u equals negative z squared minus 3z minus 3, the differential du is negative 2z minus 3 dz. So basically the top is not exactly the same thing, so we'll have to come up with to rearrange it a bit. So we multiply by negative 2, and then we divide by it. So we get negative 1/2 integral of negative 2z minus 8 over negative z squared minus 3z minus 3. Of course, I could have factor out the ln, but now we keep it like this. The right hand side, it's pretty easy. It's a ln of absolute value of x. And so negative a half. And now we split this into negative 2z minus 3. So this negative, I'm going to write minus 3 minus 5 over negative z squared minus 3z minus 3. And then minus integral of 5 negative z squared minus 3z minus 3 dz. And then it's a dz here as well. Equals ln of absolute value of x plus c. So negative a half. The first integral is basically du, integral of du over u. Then I have negative negative, so I can write plus 5 integral of 1 over z squared plus 3z plus 3, and ln of absolute value of x plus c. So negative a half ln of absolute value of u. We made a lot of substitutions, so have to be very careful. Minus 5 over 2 integral of 1 over, and I want to solve this one, and I will do it by completing the square. So it's going to be z plus half of the 3 squared, so it's 3 over 2 squared. And then what is this actually? It's z squared plus 3z plus 9 over 4. So in my problem I had plus 3. So 3 minus 9 over 4, it's actually 3 over 4. So it's plus 3 over 4, and that will create exactly what we had originally. Equals ln of absolute value of x plus c. So that completing the square is going to help me solve the problem. So negative 1/2 ln of absolute value of u minus 5 over 2. And then this one, it's integral of 1 over u squared plus a squared du, which is actually arctangent of u over a. 1 over a arctangent of u over a. So basically it's going to be times 1 over a. This would be a squared, right? So then it's 1 over square root of 3 over 2, and then arctangent of z over z plus 3 over 2 over square root of 3 over 2 equals ln of absolute value of x plus c. And all we have to do is go back to our substitutions. Ln of absolute value of u, what was u? U was negative z squared minus 3z minus 3 equals, and here these two with these two cancel, so we have minus 5 square root of 3 over 3 because I rationalize that. Arctangent of, we can multiply by 2 not z. So we get 2z plus 3 over square root of 3 equals ln of absolute value of x plus c. And keep in mind that z was y over x, so one more step, negative 1 over 2 ln of negative y squared over x squared minus 3y over x minus 3 minus 5 square root of 3 over 3 arctangent of 2y over x plus 3 over square root of 3 equals ln of absolute value of x plus c. And of course, this can be arranged a little bit more, like for example, this negative can be factored out, and because ln of negative quantity is going to be ln of the quantity. And also here I have too many fractions, so we can arrange it a little bit more.